B. So continuing with 1B.7 Part B, you have estimating fuel efficiency from driving data. Essentially, you have this article, often cite the most fuel efficient speed driving a typical mid-sized car to be 55 miles per hour. So like when they're telling you the best miles per gallon in your vehicle, it's based off of someone who's driving 55 miles per hour. But is this statement true? And if so, where did the information come from? So in the late 1990s, the Federal Highway Administration conducted a study to compare the speed of a car, miles per hour, with its fuel efficiency or mileage in miles traveled per gallon of gasoline. The following table displays that study. So if a person was driving 15 miles per hour, they ended up using 24.4 miles per gallon. Does that make sense? If the person was driving 20, this is how much they use. Okay. So what you're going to be doing is modeling. Your data is given to you, but you're going to be using this information to create a quadratic model. Okay. A quadratic regression model using our handy dandy technology. Now you have the choice to use the TI-84. If you like doing TI-84, by all means, you definitely can do it. It's the exact same way that we did for linear functions, but instead of pressing for linear, you would press for a quadratic. Okay. So if you are a handheld person, I like when there's a large set of data, it's just a little bit faster to type it using Desmos, just because it's a keyboard and I can type the numbers in faster. I also like the feature of Desmos that when there's a pattern, if I just hit enter after typing the first two, it continues the pattern all the way down. So I find that pretty useful. So what you're going to be doing is you're going to determine the best model, the quadratic regression model for this problem. Find the maximum value of the quadratic. So meaning what speed should I be going to get the most out of my gas? Does that make sense? So what speed should I be maintaining? And then how does that compare to what the FHA said? Is it 55 miles per hour? Or how much off were they? What was the big difference? Okay. So what I would like for you to do is you're going to find a partner. And I want you to use your notes, talk through this, and you're going to work on these problems together. So let me show you what I'm going to show you. So remember to reset in Desmos, you're just going to hit refresh. Okay. There's no save, there's no undo for the most part. Just hit refresh. Literally refresh your page and it will reset your Desmos. Okay. Remember that adding your table and that you can type out the regression model that you want, but is it necessary anymore? No, they have a little magic feature that's so nice, I guess. Okay. After you have done that, and have written your answer down, what you're going to do is then a independent one. So on your independent one, once you've kind of gotten the glitch out of it, you have an exit ticket one that you're going to do on your own. Does that make sense? So the exit ticket one you're going to do on your own, and you're going to go through finding the regression model, making sure you have the skills. But the practice one that I just showed you, I do want you to work with a partner, work through that one, and then go from there. Got it? All right. So that is the plan for the remaining of class. Can we handle that? All right. We're going to do our Part C notes tomorrow, and so we're stopping at Part B. Got it? All right. And go be great.